When we deal with cubic polynomials, we have to use the factor theorem, and this is how it goes. So when you have a function, a cubic function, and if you divide it with a factor, that basically means that when you divide it with a factor, the remainder is going to be 0. So suppose you divide fx with x plus 1, and the factor theorem says that f minus a equals to 0. Basically, it means the remainder is 0. On the other hand, if you divide fx with x minus a, that basically means that fa is equals to 0. So this is the factor theorem. If it was divided by something and it had a remainder, then it would be f minus a equal to the remainder. That is the idea. So let's do this. Question number A. So we have to form two simultaneous equations. So first of all, fx has a factor x plus 5. So we can write for, so f minus 5 equals to 0. Factor means remainder is 0. So x plus 5, we write minus 5 equals to 0. So let's put the value over here. So fx means x cubed. So instead of x, we write minus 5. So minus 5 cubed plus p, instead of x squared, we write minus 5. So minus 5 squared minus 11 minus 5 plus q equals to 0. So this is going to be minus 125 plus minus 5 squared is 25p minus minus plus 55 plus q equals to 0. So this is going to be 25p plus q. Now 155 minus 125 is, so 155 minus 125. This is minus 70. So let's bring this to the other side. So it would be plus 70. So this is equation 1. Next, we have to use x minus 3 as a factor. So for x minus 3, so since this is negative, it is going to be positive 3. If it is plus a, we write minus a. If it is minus a, we write plus a. So f3 equals to 0. 0 is the remainder. That means let's put the value of 3 in the expression. So this would be 3 cubed plus p into 3 squared minus 11 into 3 plus q equals to 0. So now the equation is going to be, so we can write 27 plus 9p minus 33 plus q equals to 0. And this is 9p plus q equals to, so 27 minus 33. 27 minus 33. This is minus 6. So this is going to be plus 6. This is equation 2. So we didn't have to solve this. All we had to do is form the simultaneous equations. So let's write down the answer. So the simultaneous equations are 25p plus q equals to 70 and 9p plus q equals to 6. So these are the two simultaneous equations. Next, we have to solve these two simultaneous equations. So let's do that. So question number B, we have to solve the two simultaneous equation. So 25p plus q equals to 70. This is equation 1. And 9p plus q equals to 6 is equation 2. So what we have to do is solve by elimination. So we can change the sign. So q and this q cancels. So 25 minus 9 is 16p and 70 minus 6 is 64. Therefore, p equals to 16 3s are 64, so p equals to 3. And we can put the value of p in the second equation. Seems simpler. So we can put 9p is 3 plus q equals to 6. We're putting in this equation 9p plus q equals to 6. Therefore, q equals to 6 minus 9 3s are 27. And 6 minus 27. So 64 divided by 16 is 4. So let's put the value of p in the, this is easy, this seems easier. Either way the answer would be the same. I'm putting in the second equation. So 9 into p is 4 plus q equals to 6. So therefore q equals to 6 minus 36, which is minus 30. So the answer is p equals to 4 and q equals to minus 30. So next, so we have to factorize the expression completely. So first let's put the equation in place. So fx is equals to x cubed plus 4x squared minus 11x minus 30. Now what we have to do in order to factorize this, we have to do long division. Now when we factorize a cubic expression, we do long division. When we factorize a quadratic expression, there are a number of ways. One of the main way is middle term break. So let's do this. Now we know one of the factors, we can divide it with any of the factor, but one of the factor is x plus 5. So let's use x plus 5. So we have to divide it with one of the factors. So you write x plus 5 like this. So x cubed plus 4x squared minus 11x minus 30. So the first idea is this. We want to match x cubed. So with what do we multiply x so that we get x cubed? So it is x squared. X multiplied by x squared is x cubed. So let's write x cubed over here. Now we have plus 5 with it. So plus 5 into x squared is plus 5x squared. So that's the first idea. The first idea is to match this x cubed with this x cubed and multiply with the leftover of the factor. Now what we do, we cancel this by changing the sign. So this is plus, so we are writing minus over here, and this is plus, we are writing minus over here. So x cubed and minus x cubed cancels. So what we have left over is plus 4x squared minus 5x squared, so which is minus x squared. And now we can write this thing minus 11x over here. So now once more we have to check with what do we multiply x to get minus x squared. We don't have to match the 11x, we just have to match the minus x squared. So it is going to be minus x. So x into minus x is minus x squared. 5 into minus x is minus 5x. So again we have to change the sign. So this is minus, we are writing plus, this is minus, we are writing plus. This is the new sign. So minus x squared and plus x squared cancels off. What we have is minus 11x and this is plus 5x. Remember the new sign is plus. So this is going to be minus 6x. Now the leftover is minus 30. We write it over here. So x into minus 6 is minus 6x. Remember we just have to match the first one. So this is minus 6x and we have 5. 5 into minus 6 is minus 30. So sign change, sign change. So this two cancels and this also cancels. So we have completely factorized it. Again, notice that when we factorize something, initially it was cubic. So we already knew one of the linear factor, and this is going to be a quadratic factor. Now, to factorize an expression completely is to have only linear factors. So now we have to break down this quadratic expression. So let's write, we know x squared minus x minus 6. So equals to, so x squared, so we need 3 to the 6. So minus thrice x plus twice x. Remember the sign, we need minus x. So twice x minus thrice x is minus x minus 6. If we take x common, it would be x minus 3 plus 2 common, it would be x minus 3. So it would be x minus 3 and this would be x plus 2. So we have factorized this. And remember, one of the factors was x minus 3 that was given in the question. One factor was x plus 5 and the other one was x minus 3. So the answer is going to be, to factorize the expression completely, so fx equals to, so the linear factor x plus 5 and the quadratic factor has to be broken down into x minus 3 and x plus 2. So that's it. The final question is sketching. Now remember, if it's an equation, it can only be sketched if it's a Cartesian equation, meaning it has to have both x and y, two variable equation. So here they have given y equals to fx. So now we have y equals to x plus 5, x minus 3, x plus 2. The same as the original cubic. This is also cubic. So in order to sketch, the three steps are, first of all, find out where does it cut the x-axis. That means when y equals to 0, what are the values of x? This is step 1. So let's find that out. So at x-axis, y equals to 0, since we already have the factors, it is x plus 5, x minus 3, x plus 2 equals to 0. Therefore, x equals to minus 5, or x equals to 3, or x equals to minus 3. So we have the three values of x. Next, we have to find out where does it cut the y-axis. Y-axis means x equals to 0. So where does it cut the y-axis? So at y-axis, x equals to 0. That means y equals to 0 plus 5 is 5, 0 minus 3 is minus 3, 0 plus 2 is 2. So 5 into minus 3 is minus 15, minus 15 into 2 is minus 30. So it cuts the y-axis at the point minus 30. Now the final step is to know the shape. So if you have plus x cubed, the shape is like this, nu shape. If you have minus x cubed, the shape is un. This is what the shape is. Our picture is plus x cubed. X into x into x is plus x cubed. So let's do the sketching. So the first is the y-axis. Then remember to label the x-axis. Then the origin. So it cuts the x-axis at minus 5, it cuts the x-axis at minus 3, and it cuts the x-axis at 3. So, no, not 3. This should be minus 2. Okay, so this is minus 2 and this is 3. Okay, so now the shape is this, and it cuts the y-axis at the point minus 30. The shape is plus x cubed is nu. So you have to be very careful about where the turning point is. The turning point, meaning where the curve turns, it has to be more or less between. So this is minus 2 and 3. So between them is here. So the shape is going to be like this. This is going to be the shape. This is very, very important that the turning point here is between minus 2 and 3. It's slightly on the right hand side of the x-axis, of the y-axis. This is a big question. We have still one more to go. They mentioned that the minimum point on the curve is A. And they said find the coordinate of the point where the tangent. So they're basically talking about a line. And that line is a tangent line. Tangent at A meets the curve again. If you want to find a point of intersection between the curve and the tangent, then you need to know the equation of both so that you can solve the simultaneous equation. Now the equation of tangent is not known, so we have to first find the equation of the tangent. So equation of a line is y minus y1 equals to m x minus x1. All you need to know, where does the point pass and what is the gradient of that particular line. Now the gradient of a tangent is the same as the gradient of a curve. So for that we need to know the gradient of the curve. But what about the point? How do we know the point? Well, the point is the minimum point. And the rule for the minimum point, they mentioned it. The rule for the minimum point that it has to be at the turning point, the gradient is 0. So let's do this. First of all, let's find the value of dy by dx. So y equals to x cubed. So I'm using the unfactored version because for this particular sum it is easier to use the unfactored version. So plus 4x squared minus 11x minus 30. So let's differentiate this. So dy by dx, so I'm differentiating y, it is dy by dx, equals to, I'm differentiating this portion now. So this is 3x squared plus 8x minus 11, and the derivative of 30 is 0. So at the turning point, meaning at the minimum point, doesn't matter, minimum or maximum, generally speaking, it's the turning point. So at the turning point, dy by dx equals to 0. That means 3x squared plus 8x minus 11 equals to 0. So let's do middle term break. 3 11 the 33. So 3x squared plus 11x minus 3 is we get plus 8. So equals to 0. So if you take x common, this would be thrice x plus 11. If you take 1 common, it would be thrice x plus 11 equals to 0. So this is going to be thrice x plus 11 and x minus 1 equals to 0. So therefore, x equals to minus 11 by 3 or x equals to 1. Now we have already sketched the picture, so we don't need to know by the second derivative rule which one is maximum and which one is minimum. It is clear this value is minimum. That means the positive value x equals to 1 will give us the minimum point. So that's pretty clear. So let's find the point, because the point has both x coordinate and y coordinate. So at x equals to 1, what is the value of y? Y is 1 cubed. Be careful to put it in y. We want to know y. We don't want to know dy by dx. So please be careful. So this will be 1 cubed plus 4 1 squared minus 11 into 1 minus 30. So this is going to be 1 plus 4 is 5. 5 minus 11 is minus 6. Minus 6 minus 30 is minus 36. So we have the point A. So A has coordinate 1 minus 36. Now we have to find the equation of the tangent at the point A. Now remember, if you have a minimum point like this, and if you have a tangent, the tangent is going to be a horizontal line. You don't have to worry about doing this, y minus y1. So the tangent at the minimum point is going to be a horizontal line. It's going to be y equal to some number. So since the y coordinate is minus 36, so the equation of the tangent, we don't have to worry about all the rules that we have. We just write equation of tangent is y equals to the y coordinate, which is minus 36, and that's all. And that's all. And now we have to find where does it cut the curve again. So now take a look over here. If we draw a line over here, a horizontal line, since minimum point, if you have a tangent at the minimum point or the maximum point, they're just horizontal lines. So it's going to intersect the curve again at a particular point. So we have to find that. So this question is not as difficult as it seemed at first. So let's find that. So when y equals to minus 36, so this is going to be x cubed plus 4x squared minus 11x minus 30 equals to minus 36. So it turns out to be x cubed plus 4x squared minus 11x plus 6 equals to 0. Now this is a cubic equation, and in order to solve this, what we need to know is, so we can only solve this by factoring it, and that can be done by long division, but we don't know what the factor is. In the previous cubic question that we did, we already knew one of the factors, x plus 5, but here we don't know. In this situation, we have to find the factor by trial and error. A factor is what makes the entire expression 0. So before finding that, let's check what it could be. Usually it is either 1 or minus 1. So let's check. If this entire expression is fx, then what makes fx 0? What value of fx is 0? So if I put here 1, 1 cube is 1, plus 4, 5. 5 minus 11, 1's are 11, so minus 6 plus 6. So x equals to 1 makes the entire expression 0. That means if 1 equal to 0, that would make x minus 1 a factor. So x minus 1 is a factor of x cubed plus 4x squared minus 11x plus 6 equals to 0. So since we know this is one of the factor, so what we can do is we can do long division. Hence, so x minus 1, x cubed plus 4x squared minus 11x plus 6. So let's factorize the expression. So the first thing we need to do is match x cubed. So x into x squared is x cubed. So minus 1 into x squared is minus x squared. So sign change, sign change. So x cubed and x cubed cancels. So 4x squared plus x squared is 5x squared. And now we have minus 11x. 5x squared minus 11x. Now we have to match 5x squared. So x into plus 5x is 5x squared. X into plus 5x is 5x squared. So minus 1 into this is minus 5x. So again, let's change the sign. So 5x squared minus 5x squared cancels each other off. So 5x minus 11x is minus 6x, and now we have plus 6. Now again we have to match minus 6x. So x into minus 6 is minus 6x. Minus minus plus 6. So sign change, this cancels, this also cancels. So we have a quadratic expression. So let's break this down. So we know x squared plus 5x minus 6 equals to 3 to the 6, x squared plus thrice x plus twice x minus 6. If we take x common, it becomes x plus 3. If we take 2 common, it becomes x minus 3. So this doesn't work. So let's cancel this and start all over again. So x squared plus, so we can also have 6 ones are 6. So 6x minus x, we get 5x minus 6. There are more than one way of middle term breaking, so we can use the other one if one doesn't work. If you take x common here, so x plus 6. If you take 1 common here, it becomes x plus 6. So this is x plus 6, x minus 1. So now we have the two factors. Now let's get back to the original equation. So this is the original equation that we need to solve. So hence, so one of the factor is x minus 1, and the other factor is x minus 1, and the other factor is x plus 6 equals to 0. So therefore x equals to 1 or x equals to 1 or x equals to minus 6. So which coordinate can it be? It cannot be positive, because if you take a look at the sketch, the tangent has to cut the y-axis, the tangent has to cut the curve at a point which is going to be here, around here, a negative point. So that has to be minus 6. That is logical. So our answer, where the tangent again meets the curve, is going to be x equals to minus 6. So x equals to minus 6, and y we found is minus 36. So notice this is basically a cubic question. Everything here deals with mainly cubic. When factors are given, how to find the constants, and then at the end of the question, when you have a cubic equation and you have no known factors, how to use the calculator to figure out a factor by yourself and then factorize it and solve it. So the entire question deals with solving cubic equation.